Hello guys, and welcome back to another episode of chemistry, and we are going to continue on our study of electrolysis as we look at the Faraday's second law of electrolysis. Okay, it's a very interesting and entertaining topic. And in the previous episode, we talked about the first law, right? And in this second episode, in this next episode, we're looking at what the second law of Faraday, the Faraday's second law of electrolysis. Okay, now what does the law state? Okay, know that this video tutorial is brought to you by the O3 Schools JAMB app. It is all you need to succeed in your exam. So please, it has wonderful features like the classroom feature where you can study. It has the classroom feature has lecture notes also. Okay, it also has the question search feature where you can search for question by topic. Like you can just go to the app now, go to question search, click on chemistry, then search for electrolysis. All the questions that JAMB has set under electrolysis will come out why for you. You'll be answering them. Interesting, right? Before you move on to the next topic. Okay, then also it has a wonderful feature called the UTME challenge. It's a challenge that will conduct for all students that are writing JAMB for a particular year. Okay, so you are competing to win prizes every Saturday till 1 week to the exam. So as you are doing that, you are getting used to how JAMB set questions, you are gaining confidence toward the exam, and you are seeing your result. So because you are seeing your result every week, because it's like a mock, okay, and it's a competitive mock. So you are seeing your result every week, you are gauging how prepared you are, you are seeing how you are improving. Okay, so please do not sleep on the app. Go to Play Store right now, download it, and activate it. Activation is just 3,000 naira as at the time of shooting this video. It may increase over time. So please pass your exam at once. Pin your bomb in one place and read and pass your exam at once. Okay, to activate, just go to the app, click on activate. At the top, you see where they wrote buy activation key. You can use your ATM card. You can make a direct bank transfer to the O3 Schools app account. You must make sure it is O3 Schools. Okay, it's a money point account or the Zenny bank account. Make payment to any of the accounts, and of course, make sure you send your receipt to this number on WhatsApp 09121515246. Right? Anybody can pay for you, your father, your mother, your auntie. All you need is the receipt. Tell them to send you the receipt and forward it to us on this number on WhatsApp. Okay, or you can just call in for activation. Okay, so let's, without further ado, talk about the second law of electrolysis. Faraday's second law of electrolysis states that if the same quantity of electricity is passed through, right? They pass through different solutions of electrolytes containing ions, right? Such as A plus, for example, B2 plus, and C3 plus, right? If the same quantity of electricity, the same Q, right, quantity of electricity, it passed through different solutions of electrolytes containing ions A plus, B2 plus, C3 plus. Okay, what is now saying next is that the amount, not the mass, so please, the amount, not the mass, right? But number of moles of substance deposited at the electrode, right, is inversely proportional to the charge on the ion in the solution. Please take note of this second law. It is not difficult. It is not by any means difficult. It states that if the same quantity, look at it, the same quantity of electricity pass through different solutions of electrolytes. Okay, that is what the law is talking about. And they say the amount, right? The amount, not the mass, so the number of moles of substance deposited at the electrode is inversely proportional to the charge on the ion in the solution. Okay, if the same quantity of electricity is passed through different solutions of electrolytes containing ions, this different type of ions, A plus, you can see this one is univalent ion, this is a divalent ion, this is a trivalent ion. They say the amount, not the mass, but the number of moles, right, of substance deposited at the electrode is inversely proportional to the charge on the ion in the solution. Okay, so here what I'm talking about mostly importantly is what talking about the quantity, the same quantity of electricity passing through what a different solution of what of electrolyte. Okay, and I'm talking about what the amount in being inversely proportional to the what to the charge amount inversely proportional to the charge on the ion in the what in the solution. Okay, this means that what that the higher the charge, right? This means that what that the greater the charge on the ion in the solution, right? The lesser the number of moles or lesser the amount of substance deposited at the electrode. Okay, because there is an inverse proportionality, as you can see here. Where is it? Where is it? Where is this? Where we say okay, yeah, where we say it is inversely proportional to the charge on the ion in the what in the subs in the what in the solution. Okay, that means that what the higher the what the higher the charge on the ion in the solution, right, the lesser or what the lower or all right, or the lesser the what the amount of moles on what of the substance deposited at the electrode. Okay, this means that what this means that the higher the charge on the ion, right, the higher the charge on the ion, right, in the solution, comma, right, it means what the lesser, right, the number of moles of substance deposited at the electrode. Okay, so please, it's very easy to understand. If the same quantity of electricity pass through what different solutions of electrolyte containing what ions A plus, B2 plus, C3 plus, they say the amount, not the mass, but the number of moles of substance deposited at the electrode is inversely proportional to the charge on the ion in the solution. This means that what the higher the charge on the ion in the solution, the lesser the number of moles. Okay, you can see the higher the charge, right, the lesser the number of moles. Okay, so this means that the higher the number of moles, that means what the lesser the charge, because there's an inverse proportionality. That means that if the charge is going up, if the charge is what is much, the number of moles will be low. If the number of moles is much, the charge will be low. It's that simple as possible because of this inverse proportionality. Okay, so now let us see an example. Example of let's consider the effect of passing, for example, 6 Faraday of electricity through what different electrolytes having containing the ions, let's say Na plus, this is a univalent ion, let's say Ca2 plus, which is a divalent ion, and of course let's say what Al3 plus, which is what a trivalent what ion. So let's consider the effect of passing the same quantity of electricity, 6 Faraday quantity of electricity through what electrolyte containing what this what ions, Na plus, Ca2 plus, and what Al3 plus. So we can calculate the number of moles, right, liberated, right, by this same quantity of what of electricity. Now let's look at it. Let's take this off so that what we can what have what a wider space to what to explain it. Now please know this for second law is very easy. If the same quantity of electricity pass through a solution of what different electrolyte containing ions A plus, B2 plus, C2 plus, the amount, not the mass, but number of moles of the substance deposited at the electrode, right, is inversely proportional to the charge on the ion in the solution. It means that whether the higher the charge on the ion in the solution, the lesser the number of moles of substance. We are going to prove it when we consider the effect of passing this same quantity of electricity, 6 Faraday of electricity, through what this what ions. Okay, let's see. For example, we are considering the effect of passing the same quantity of electricity, 6 Faraday, right, through what different electrolyte containing what this what ions. Okay, now let's see. For Ca2 plus, for example, so that's sorry, let's start with Na plus. That was Na plus. Okay, you can see that Na plus is univalent. It's univalent. That means it has what the valency of plus 1. You can see here. This one is divalent, it has plus 2. This trivalent, that's what plus 3. This means that what that 1 Faraday, right? 1 Faraday yields 1 mole of Na plus. Reason is that what? Na plus is what? Is univalent. Okay, 1 Faraday yields what? 1 mole of what? Na plus, right? Because what? Na plus itself is what? Is univalent. Okay, it has a valency of 1. That's what it you need what? 1 Faraday. 1 Faraday will what? Will yield what? 1 mole of what? Na plus. Okay, now what about 6 Faraday? 6 Faraday. 6 Faraday will what? Will yield what? We yield how many moles? We yield 6 moles also. 6 moles of what? Of Na what? Plus. Okay, now why will this happen? Look at it. Let's calculate. In case you don't understand why 6 Faraday will yield 6 moles. Look at it. 1 Faraday yield what? 1 mole. Can come to the side and do something shabby. Okay. 1 Faraday yield 1 mole. 6 Faraday will yield what? X mole. Okay. So you cross multiply, isn't it? So we are going to have X times 1, which is X, right? Is equals to what now? 6 times what? 1, which is what? 6. X is what? Is 6. That means what? It will yield how many moles now? 6 moles. As simple as ABC. That's why we say what 6 Faraday will yield what 6 moles of what of Na plus. It's as simple as what as ABC. Thus, 6 Faraday as what has yielded how many moles? 6 moles of what of Na plus. It means that what the amount of what of Na plus liberated, right? The amount of Na plus liberated by 6 Faraday of electricity is how many moles? Is 6 moles. Okay. The amount of what Na plus liberated by passing 6 Faraday of electricity through it is what? Is 6 moles. Let's make that very clear. This means that what? Thus, I just say thus, the amount of Na plus liberated by 6 Faraday of electricity is how many moles? Is 6 moles. As simple as ABC. Now, let us continue. Let us now look at the next one was what? Ca2 plus, right? Now, for Ca2 plus, you see that what that 2 Faraday yields what? Yields 1 mole of Ca2 plus, right? 2 Faraday is what? Is mole of what? Of electrons. Mole of the meaning of Faraday is moles of electrons. Okay, because what Ca2 plus is what? Is divalent. It means that 2 Faraday will yield 1 mole of what of it. Because what Ca2 plus is divalent. All right, simple as ABC. Now, 6 Faraday will yield what? 6 Faraday yields 3 moles of Ca2 plus. Why? You can come to the side and do it. And of course, you can see. Look at it. 2 Faraday yield 1 mole. 6 Faraday will yield what? X mole. So cross multiply. I'm going to have 2x is equals to 6 times 1 is what? Is 6. So x is what? 6 over 2, which is what? 3. Okay? So that's why very, very correct there. That means that what? That 6 Faraday will yield how many moles? We yield 3 moles of what? Of Ca2 plus. And this means that what? That Ca2 plus, right, is liberated what? That the amount of what? Of Ca2 plus liberated, rather, the amount of Ca2 plus, thus, you can say thus, comma, the amount of Ca2 plus liberated by 6 Faraday of electricity is how many moles? Is 3 moles. Are you noticing something? Right? For Na plus that was univalent, 6 Faraday yield how many moles? 6 moles. For Ca2 plus that is divalent, as we are saying from the law, we say well, the higher the charge, the lesser the number of moles. Okay? When the charge here was 2 plus, it yield how many moles? 3 moles. Let's look at Al3 plus now. Al3 plus. Okay? That means 3 Faraday will yield what? We yield 1 mole of what? Of Ca2 plus. Okay? Because sorry, of Al3 plus. Of Al3 plus. The reason here because what? Al3 plus is what? Trivalent. Now we are done with that. Now, having seen that, 6 Faraday now will yield how many moles? 6 Faraday will yield what? We yield 2 moles of Al3 plus. Okay, you can now say that thus the amount of Al3 plus liberated by 6 Faraday of electricity is what? Is 2 moles. Okay, so from our hypothesis, from our experiment so far, we are able to see that what? That when what? When the ion was what? Was univalent. Okay, it yielded what? 6 moles. When it was divalent, it yielded what? It yielded what? 3 moles. When it was what? Trivalent, it yielded what? 2 moles. For the same quantity of electricity that was passed through them. That's when the second law was saying that what? If the same quantity of electricity, right, is passed through a solution of different electrolyte containing what? Containing different what? Containing what? Ions, such as what? A plus, B2 plus, and what? And C3 plus. Right? We're told that what? That the amount, right? Not the mass, but the number of moles of the substance deposited, right, at the electrode is inversely proportional. The amount is inversely proportional to the charge on the ion in the solution. This that we explain further by saying that what? That the higher the charge, as you can see, Al3 plus, the higher the charge, the lesser the number of what? Of moles. As you can see, 2 moles here. And the higher what? The lesser the what? The charge, the what? The higher the number of what? Of moles. The higher the charge, the lesser the number of moles, right? The lesser the charge, the higher the number of moles. Okay? It's as simple as ABC. Okay. Now, having seen this, we just want to open our mind to understand what the second law, what is saying. And where will be highly tested is when it comes to what? To the calculation. Okay? So please make sure that you open your mind. Now, what does F means? What does Faraday means? Faraday means moles of electrons. Faraday means moles of electrons. We put that down. Faraday means what? Moles of electrons. And for the purpose of calculation, it is important that what? You remember what? This formula I'm about to put on ground. It can solve any question that borders on what? On electrolysis. On the first law, we already knew that what? That Q. We already know that Q is equal to what? IT. From the first law of electrolysis, we knew that what? Q is equal to what? It's equal to IT. So now, having known that, from this second law, know this formula, know it and what? And know peace. Okay, that RAM equals to what? MCF over Q. Please note this formula. It is what? Very vital. RAM is equal to what? MCF over Q, where RAM is what? Is relative atomic mass. Okay, where M is what? Mass of the substance. All right, and where C is what? Is charge or valency. Okay, this is MCFO. Okay, and of course, where F is Faraday's constant. Faraday's constant. Okay, which is what? 96,500 coulomb. And then, of course, Q is quantity of electricity. Quantity of electricity. Okay, so please, this formula can solve any question. Where I told you that Faraday, F here means what? Faraday, F means what? Number of what? Moles of what? Of electrons. Okay, moles of what? Of electrons. That's the meaning of Faraday here. Okay, so now please take note of this formula very well. It can solve any question as it relates to what? Electrolysis. Okay, sometimes we will not be given what this parameters the way they are here. So we can now use what? Q equals to IT to what? To blend it and so on and so forth. Sometimes we maybe we need what? Mass over molar mass to find the number of moles. Okay, so wherever, however, just know that what is just what is just it's just a child's play when it comes to what? Solving questions on what? On electrolysis. Okay, so please, in the next episode is dedicated to what? Solving questions on electrolysis from the O3 School JAMB app. Please make sure that what you have downloaded the app, and make sure make sure very well that you have activated the app, and because I'm going to give assignment and it's going to come from what, from that application. All right, so please, without further ado, all right, this is Faraday's second law of electrolysis, and this is what the formula we're going to be using. Please know it in your head. RAM is equals to MCF over Q. Very vital. In the next episode, I'm going to see you where we'll start doing calculations in electrolysis. Thank you for watching. My name remains Master T, your favorite chemistry teacher, and I will see you in the next episode.